Hello, everyone. Thank you for joining us today. My name is Mark Bernardis, and I am the Communications and Marketing Officer for the Department of Chemical Engineering here at UCL. Thank you for joining our Spring into STEM Kickstart Your Journey as a Chemical Engineer at UCL virtual lecture series, presented by Elton Dias, lecturer at UCL Chemical Engineering. So the session will run approximately 1 hour from 10 to 11 a.m. London, UK time. And it will be recorded and shared with you in the next few weeks on the UCL Spring into STEM landing page. There will also be an opportunity to complete a feedback form after the session. And we'd really appreciate your feedback so we can make improvements to our next events. So without further ado, I'm going to pass you over to Elton, and he's going to present the session now. Thank you.
Hi, good morning, everyone. Thank you, Mark, for the introduction. So today I want to show you how we kickstart your journey as a chemical engineer here at UCL. Now, we won't be teaching you here what is your first year and second year, but rather showcasing what are the things that we teach you. So what contents do we cover, why do we cover them, and how they make you a better chemical engineer in the long run. So you will hear a lot of the time that I'm referring to you and you as a prospective student or someone who is interested in joining UCL Chemical Engineering. So let's start with this. So what are we covering here today? So first we start with what do I do at UCL? So why would you listen to me, right? Okay. And next we go and explain what is the IAP, and what is the IAP? That's a good question. What professional skills? Why is my obsession with professional skills, and why is this important for chemical engineers or any engineer? We'll ask if you are ready for your first engineering challenge and how we do that in your first year here at UCL Chemical Engineering. And then we will show you a lot of the opportunities that you have to be a chemical engineer for a full week. And now that's no easy ride, okay? But we'll get more in details about that later. And finally, we'll finish with professional accreditation. Why is this important, and what are the benefits of doing a degree here at UCL? Okay, so who am I? As Mark said, I'm a teaching-focused lecturer here at UCL Chemical Engineering. So what are teaching-focused lecturers? As opposed to a lecturer that has a research group and their main role is to do research, and they also do some teaching, my main role here at UCL Chemical Engineering is to teach. That's the only thing I do. I will do research in engineering education to make sure that we can provide the best services and the best content and ways to teach to anyone. But my primary focus is to teach. So that means that the quality of teaching you can expect from a lecture teaching potentially will be high because our commitment is just for teaching. Okay? So I teach Design and Professional Skills 1. So we'll cover that in a bit, what this module entices. I also teach engineering challenges, scenarios, and mathematical modeling and analysis too. So this is a module that you have in your second year. My academic interest, so I have a PhD in photocatalysis using solar light and hydrogen production. And in the past, I've worked in power systems, carbon capture and storage. So I have interests in power systems, but also with sustainable energy sources. Okay. And lately, for my engineering education, I've been interested in the gamification of education. So a lot of the topics are very dense and hard to follow, hard to understand, and frankly, what some students say, that they are boring, but they are necessary. They are very important and necessary, but it's just a difficult topic. So I've been looking into ways of gamifying this knowledge so that you can play and at the same time learn something. Okay, so this is an example of our latest efforts in that myself and the PhD student, we are creating a card safety game. Okay, in this case, what you're looking at is to the poster that we released to all UCL so that any student could participate by submitting artwork for this project, and all the students would earn a £150 contract to produce artwork for our card game. As you can see, being part of UCL, that does not just restrict you to being in chemical engineering, it's a whole door that opens to you of content and things to do and groups interests that you can develop here at UCL. Okay, now let's get into content. The IEP. What is the IEP and why is it important? So the IEP stands for Integrated Engineering Program, and it is an award-winning undergraduate teaching framework that most engineering programs here at UCL are part of. So it is not a program that you apply directly, but rather a teaching framework. So for instance, chemical engineering at UCL is part of the IEP. And that means that we follow a specific philosophy, a specific way to teach content, not just for the technical, because that will be different for each module, but commonly in terms of other skills, what is important for an engineer. So for instance, the IEP emphasizes creativity, communication, interdisciplinarity, and teamwork by learning through projects and social context of engineering. Furthermore, the IEP believes that engineering is about people. And the IEP will help you to explore, build, and design engineering solutions that make a difference. So an engineer is only useful if you can produce something that is useful to society. That is the definition that the IEP follows, and this is the same philosophy that we apply here in chemical engineering or biochemical, biomedical, or all the other engineerings at UCL. So there will be some links throughout the presentation, and Mark will be posting them at some point in the presentation. So these links will include all the information that I have here, for instance, for more information about the IEP, but there will be other ones. Okay, now that we understand how the IEP is important for us, let's have a look to why professional skills. Why am I obsessed with professional skills? Now, you would think, I'm coming to the university, I'm looking to learn a technical subject in depth. Why is this person, why is Elton talking to me about professional skills? Well, don't take my word for it, because according to the World Economic Forum, in 2015, the top 10 skills do not include technical skills. What they include is that they are looking for people that are able to solve complex problems. They were looking for people that were able to coordinate with others, have people management, critical thinking. So not just accepting what is in front of them, but also criticizing and questioning. People with the negotiation skills, quality control, that really are proud of what they produce. So that's perhaps would be your technical knowledge coming here, that you are proud and you are really sure of what you're presenting. Service orientation, so that's the predisposition to cooperate and be helpful in your workplace. People with judgment and decision-making capabilities. People who are able to actively listen, and creativity. So this is a very interesting one that in 2015 was the 10th in this list. So how things have changed now from 2015 to 2020? Let's have a look. So as you can see, complex problem solving is still the first one. So you can see the importance, how to solve problems. And I mean that not just at a technical level, but how do you tackle problems? Even if it's a topic that you are completely unaware or don't have the technical knowledge, how do you would go about solving that specific problem? We can see other ones that critical thinking got promoted to second place, and creativity with a huge bump to third place. So we are looking for innovative solutions, people with creativity and ways to think differently from what has been done before. Other things to note is that quality control and active listening were dropped from this list. So it seems that in 2020, most companies throughout the world were not looking for this type of skills, but new ones have emerged, such as emotional intelligence or cognitive flexibility, the ability to adapt in the moment to new circumstances and new problems. Okay, so I've presented you the past, I presented you the now, more or less 1 year later. Now let's just have a glimpse of what they expect, what the World Economic Forum expects for 2025. Again, analytical thinking and innovation. And I think that's a big bundle here with creativity, which is still part of it, critical thinking and creativity. but analytical thinking and innovation. Active learning. This is something that we practice here at UCL Chemical Engineering very, very much. Research, being able to go out on your own, on the internet, to a book, to a library, and find the knowledge to provide you the answers you need for your problem. Again, complex problem solving, third place here, that's a must. But you also have leadership, social influence, and these new topics, technology, something that in the past was not very much mentioned, but now technology use and design. And here at UCL, you will see we are on the front end of using the technological tools to give you the best education possible, either in the software that is used by industry, world-class software, such as GPROMs, GAMS, even MATLAB. So these are all software that we use and you learn from year one here at UCL, and that will be part of your repertoire when you finish your degree here at UCL. Resilience. So the ability to endure and reasoning, endure but listen to others, again, connected to this emotional intelligence. Okay, so hopefully by now I've justified why we are so keen to teach you professional skills here at UCL. Now, one thing that I haven't mentioned is that these skills can be grouped into four main traits, and that will change depending on what literature you use. But the one we use is that they can be bundled into strategic thinking traits, influencing traits, relationship building traits, such as emotional intelligence, and executing traits. So people that are driven in getting things done. So here at UCL, we use the Clifton Strength Finder. So this is a commercial software that UCL has licenses. And the first thing that you start when you do teamwork is that you go on this platform and you do the test. So it takes a good 45 minutes and it has a lot of questions, I believe more than 60, but believe me, it's worth every minute of your time answering those questions. When you finish that, you will be given a report with your 5 main traits. So for instance, person 1 here is very deliberative, restorative, learner, analytical, and has a bit of relationship building traits. But if you think about this person has no traits in trying to influence the others. So it gets things done, it organizes his way, and is good at relationships, but has nothing on the blue collar, such as influencing traits. And the first thing you do, as I've said, is you go on this website, you fill this, you get your report, and then you meet up with your team and you put together your team traits. Now, why do we do this? First thing is for you to understand who you are, okay? So this is a way for you to understand, what am I good at? So either you can reinforce those skills and really use them to drive the project. So for instance, if you look at person 1 versus person 3, if you want something done, you probably talk to person 1 because this person is driven in getting things done. But if you need to group to go in the same direction, you probably get person 3, which has a lot of skills in influencing traits to convince everyone to move in the same direction. Okay, so as I said, you can either drive with the things you have, or you can look at the other things that you don't have, so that you can start developing skills in those areas so that you become a more well-rounded engineer with different ways to work with different people. Now, this is this data that you are seeing here, they're actually real, and I will tell you, person 1 is actually myself, and that was myself 2 years ago. Now, we had PGTA, postgraduate teaching assistant, and that's a PhD student that supports the teaching in class directly. And this person did the test 4 years ago and did the test now again. And it's important to notice that before, this person was very much competition driven, and now they actually try to get things done before competing with others. And meanwhile, he has developed also relationship building traits. So it seems that throughout these 4 years, they have developed that they actually need to interact with others in a way that is meaningful. So as you can see, this is a very interesting tool, and we recommend every time that we start teamwork, and there will be plenty of opportunities, as you will see from this presentation. Everyone comes together, looks at how the strengths of the team are put together so they can understand what roles should each one of them do. Okay? Now, the module is called Design and Professional Skills, and so far I have touched on professional skills. So let's talk a bit about design. But for that, I'll have a bit of water. So let's look at this problem. How do you cross the road? You don't need to have any technical knowledge to cross the road, except you need to understand that you need to look left, right, find your zebra crossing, and if that is not available, look left, right again, check again, and see if you can cross the road without hurting yourself or anyone else. Now, as you can see, this thought process, it is indeed a process, and you are solving a problem. You might not acknowledge it, but you are actually solving a problem. I want to cross the street. You have identified your needs. I want to go from here to that side. That is your brief. And now you develop a process of how you're going to do that. Now we do that automatically every day in our lives. Every time that we do something, we do that automatically. But here, what is the difference between then or me asking you, how do I produce a vaccine, for instance? What is the difference? Now you might have or not the technical knowledge, but the question is, how would you tackle this problem? Okay, so that's why we help you with tools. We teach you tools that help how to develop your design or improve your design. So there are different tools, and these are one of the few ones that we touch here, such as systematic innovation by design, where you explore and try to understand what exists, what the problem is. You try to create, and then you try to implement. So this one is a very linear process. You have a problem, you create a solution. You want to cross the street, you cross the street. Great. Now, there are ways that you can think about your problem that you can change and adapt and potentially even come outside of the brief to really improve the way things are done. For instance, a classic example that we use with the design arch is the smartphone. When they created the phone in the first place, what they wanted was to just make calls. But meanwhile, someone asked, what if we could have access to the internet through it? And at the beginning, that was just to do some research, to have some sort of dictionary, library with you the whole time. Eventually evolved to being the smartphone as we know today. So instead of going from left to right, they tried to go into a more abstract dimension. What could we do extra with this, besides just making a phone call? Now, the other one that we use here a lot at UCL, and you actually be taught in the first year, it's the design cycle. And the biggest advantage of the design cycle, it is iterative on many dimensions. So as you can see, we develop the need, we develop a brief, you conceive, test, specify, make, use, and then you go and review the need. Is what I'm doing or what I'm producing fulfilling the need? If not, you can go again in the cycle. So that's why it is a cycle. It allows for multiple iterations, and you can have multiple versions of your product as it evolves over time. Again, I won't be here to explain what is the design cycle today, but to show that these are the tools that we have. Now, the next one is engineers need to produce useful solutions. So that's the whole spirit of the IP, as I explained before. So whatever solution you are creating, first, it needs to be feasible. We have to have the technology in place. And you are the one that will be assessing, is this possible? Are there research out there that can help me get what I want to be done? Second, is it desirable? Does it fulfill the human values? Do you think people would be accepting of your project? So should we start thinking of going back to coal? Well, according to the current human values, that would not be desirable, okay? And the third one, is it viable, okay? With all these conditions, is your business viable? So is it just you're producing a great product, but at what costs? And is it at the cost that people, your clients, are willing to pay for it? Again, these are the questions you will be answering. And if you find that your product is here in the middle, what is called the sweet spot, That's what we are aiming for. That is your design innovation right there. A product that fulfills all of these conditions. Now, how we do that? We have lectures every week in design professional skills. You have a lecture with a different topic. We have one for creative thinking, and it's just a clip of a slide that we have in creative thinking. That one is a very relaxed lecture where we draw each other upside down, where we think about what is convergent thinking, what is divergent thinking or chaotic thinking, why is it important, why is it useful, why does feedback and judgment actually hold us back when we're trying to be creative, what are the factors? So children are deemed to be creative, but what has changed between being a child and being an adult? Why did we stop being creative or assuming that we are creative? Okay, so we cover all these aspects, again, to try to unlock your creativity, giving you tools to unlock your creativity. Now, creativity is all good, in my opinion, as long as it goes somewhere, right? And that's why we also need critical thinking. Again, that was the second or third points in the professional skills that are top 10 according to the World Economic Forum. Here, we do a full lecture on using Socratic questioning. So this is a very known tool with a series of questions that you have here and that are applicable to your problem or to your product, so you can see where your product sits. So with that, you can develop your critical thinking capabilities and really decide, is this useful before you go any forward, okay? Now, you know how to solve problems, you know how to generate new ideas with your creativity, you know how to understand if those ideas are useful or not, but you still need to divulge them. And that's where technical writing comes into play. We also teach you how to effectively transmit your information, either if it's through a presentation, either if it's through a report, how to give feedback to others. So just going here from the top, how to understand your audience. This is very important. How to provide enough explanations, and the most important explanations for your specific audience. What should change in your language if you talk to a CEO of a company or if you're talking to an engineer on site? What would be the difference? What are the things that these people will be looking for when talking to you? So here you will have plenty of opportunities with different audiences so that you can discuss and really appreciate what key information you need to put forward in each case. Technical argument. So with fake news being a very common thing these days, how do you make your argument using technical data? How do you support your discussion using technical and true data? We cover here technical argument. Visualization, how to be appreciative of graphs and charts. What is wrong with the most of them? What is good? What things you should look out for? We have plenty of examples of things that come out in magazines or newspapers of graphs and charts that are fundamentally flawed, that you as much as you try to analyze, you don't fully understand what are the things that are being there. Not because it's something wrong with you, but because they were not created well defined in the first place. So here we teach you how to visualize data, but more importantly, how to generate your own graphs in the best way that are the most informative as possible. Building text. So that was the bit I was talking about, writing. Another one that is very important, referencing and plagiarism. Acknowledging when you obtain data or information that was not yours in the first place, you need to be humble enough to say, this is not from me, this is from this source, because this needs to be acknowledged. And in this world where it's so easy to go on the internet and just type something, is the earth round, you need to be able to tell us or tell your audience where you obtain that information from. Outlining and feedback, the ability to summarize content, but also provide feedback, okay? Provide feedback in a constructive manner, something that if you give back will actually increase the value of what was already there. And finally, presentation. How do you present? How to create the best slides possible that to keep your audience engaged. Hopefully my slides today are fulfilling that role. Now, we also teach a bit of risk and safety in design professional skills. And the idea of that is to try to input in you the characteristics of chemical engineering and why risk and safety is so important. In this example, we have the Egyptian plover and the Nile crocodile. Now, in most cases, I wouldn't put my hand inside the crocodile's mouth, but this bird feels comfortable enough to be walking inside it. And it's because it has a symbiotic relationship with the crocodile, where it eats any detritus in the crocodile's mouth, it cleans its mouth, and the crocodile in turn gets a clean mouth and it doesn't eat it. So it's a win-win situation. Now, why is this important for chemical engineers or engineers in the first place? Because we need to understand risk. We need to understand what is risk, how risk is perceived in general by the general public, and why it's important that we understand that. Again, at the end of the day, we are creating new products or processes or systems. So these systems need to be safe intrinsically. And you also need to understand how people will perceive those processes or these products, so that this risk can be mitigated. How will they use in the best way, in the wrong way, what you can do to prevent from being used in a wrong way, etc., etc. And safety. Why is safety so important for chemical engineering? Well, because when things go wrong in chemical engineering, things go really wrong, okay? When things go wrong in chemical engineering, we have fire explosions, potentially fatalities and injuries. So these are very serious cases. And we go through a lot of examples in our lectures of different cases, of different situations, of things when they went wrong. We also have environmental disasters. For instance, when we have an oil spillage, it's not just about the money or the lives that were lost, but also the effect on the planet. There's also major loss of assets and obviously negative impact of economies. That's why safety in the last few decades has been promoted to one of the most important things for chemical engineers, that they understand safety. And to understand safety, we need to understand risk. Okay, so you can see the whole story tying together. Now, we also have a few lectures on ethics and professional conduct. So we further give guidance on risk, sustainability. So sustainability is becoming an ethics integral part of it. While in the past, sustainability was not even mentioned. Now we have to look out for it. We have to aim for it. Okay, so here we give guidance on different tools, different analysis tools that you can employ for anything that you design for in order to improve sustainability. We try to help you answer other questions such as, who do you want to be at work? Do you want people to come to you to look for getting things done, for you to be an expert, etc., etc.? Showing respect for your colleagues. So this seems so obvious, but believe me, when things get intense and stressful, this is more important than ever. And unfortunately, that's where it gets dropped most commonly. So showing respect for others at all times, in all circumstances, understanding what is wrong, what is right, and what are the specific channels for anything. Work dilemmas, the different ways people handle them and their potential situations. So we present you with a series of scenarios where this happens, what do? You have different options, you need to justify. And with that, you are interacting with your colleagues. So that's how you develop ethics. That's how you develop your professional conduct. What is right, what is wrong. Now, why do we do all of this? Well, because we follow the standards by the Engineering Council in the UK, which is the UK regulatory body for engineering profession. Now, again, the link, I'm sure Mark will be able to give you the link later, but everything that we do, we follow the guidance from the Engineering Council. So, for instance, the Engineering Council has just released the ethics standards supplementary information. So, again, providing standards to the UK and to the engineering profession of things that should be done. Now, We have, as a guest lecturer, Professor David Bogle, that usually gives lectures about this ethics and professional conduct, and he has now been appointed the president for the Institution of Chemical Engineers. So just to see that the people that we have working at UCL are world-class researchers or teachers, people that have a big name in the area, and this is recognized here by their appointment as president of the IChemE. Now, you've got all this information about how to be a professional. You have all this information about how to tackle problems and design solutions. So you are ready to go, right? Are you ready for engineering challenge? Yes, that will be engineering challenges. So this is a module that runs parallel to design and professional skills, where you have a chance to apply directly the knowledge that you are learning in DPS. Now, you will be also introduced to departmental research. And why is this so important? So you are in a research university. Why is it important that we have research there? What can you do with it? Okay. It will be your first project in a term 1 from week 3 at the moment. And more than that, it will be an interdepartmental project. You will be working not only with your department, but also students from other departments. And doing what, you ask? Well, the project in the latest years has been the production of a tuberculosis vaccine in Uganda. Now, why I'm saying here Uganda? So you need to produce a vaccine. Okay, you will need a lot of power, you will need a lot of water, and Uganda, as it's well known, will have some difficulties in providing that. So that is a big challenge, that you can provide tuberculosis vaccine in Africa, and also start by helping the local population there and the countries nearby in Africa, where actually tuberculosis is most prevalent. Okay, so you can see the challenges that are already there. But you're not alone. This is interdepartmental. And actually, you'll be put together in an integrated engineering group, which has students from biochemical, chemical, biomedical engineering, but also electronics and electronic engineering, computer science, mechanical engineering, civil engineering. So you are all working together to provide a solution on how to create a production plant for tuberculosis vaccine in Uganda. So you will be determining what are your power requirements, so you can take this information to the power and water facilities and tell them, I need this amount of kilowatt hour. I need this amount of water for my production plant. And for electronics and computer science, you'll be providing control specifications. So you need to mix your bioreactor, you need to heat it. What are the control specifications that you deliver information to them? As you can see, all these groups, all these departments working together in your term 1. Now, you being chemical engineering, what you'll be doing, you'll be working on the reactor design instrumentation, looking at the mixing it in the reactor, heating it in the reactor, probe, monitoring, how is the population of cells growing in your reactor? Yes, so this uses cells growth to produce the antiviral agent for the mycobacteria. So you need to monitor how are these cells growing and when it needs harvesting, etc. How do we do this? Well, research. You start by doing research. You need to understand what is necessary, what you need to think about. And then you get your multi-thousand-pound bioreactor. No, I wish that was the case, but no, not even in industry. So this is hundreds or tens of liters bioreactor, and not even in industry. The first thing they do is to go to a full-size bioreactor. No, first they start with something at a pint scale. So that's half a liter scale, what is called the lab scale. Okay, and it's exactly where you start as well. So we give you a pint glass with some mixing attachments, a heater, and everything that you need to start making your testing. And once you're done with that, what do you need to do again? Well, more research. And on top of that, more research. Try to understand, why would this impeller be better than this type of impeller, which is just flat? What are the differences in the flow patterns for each one of them? Why is it important? What rotational speeds? So as you can see, there are a lot of things to consider. There's a lot of research that you'll need to do. But again, you have been exposed to what is research. You know to solve problems. You will have all the tools you need to succeed. I am sure of that. Now, I want to show you a quick one of what happened last year. So we couldn't go to the lab because of the pandemic situation. So what did we do? Well, we created your own virtual lab. We used Minecraft, the education edition, to create digital bioreactors. Each team were assigned 2 bioreactors, and these are the bioreactors. Here you can see people going about controlling the reactor, and this will be able to simulate at some degree what are the conditions. You could do all the testing using Minecraft from your laptop. So we did this last year, okay? Now we are looking forward to go to the lab again where you can actually get hands-on, but when things go wrong, we are able to adapt very quickly to the new circumstances and make sure that you get all the educational content that is necessary. Now, the final experiment for this engineering challenges is actually we have what is called a 24-hour run. So we lock the labs, and they are just for you guys, you students, for 24 hours, just on working times, and you are able to come in and out, and your bioreactor will be running for 24 hours, and hopefully at the end of it, it would show a concentration curve of viable cells, something like this, where cells are growing. This is what is called the lag phase, exponential phase, and then after that, when it reaches saturation, slowly starts dying. So this is what we expect to see, but you will have the chance to define what is the temperature, what are the mixing conditions, what is the aeration profile, so that you can obtain the highest amount of viable cells during your 24-hour run. Okay? Now, this was engineering challenges. And that was working together with other teams and other departments for a whole term. But what if I told you, throughout the degree, you will have the chance to be a chemical engineer for a week? And that is what they are, scenarios, okay? Now, you'll be thinking, but Elton, you've been talking for a while now, and you haven't said anything about technical knowledge. Fair enough. During your first term and your second term, before we get into the scenarios, you will be also having technical modules. So in this case, Introduction to Chemical Engineering, where it introduces you to mass and energy balances. So the bread and butter of chemical engineering, the development of PFDs, process flow diagrams, and PNIDs, process and instrumentation diagrams. You will also be having your first computational modeling and analysis, where you present with industry standard tools that you can use on your computer or in our virtual machines to help you solve your chemical engineering problems. More fundamentally, you will have transport phenomena, where you will understand everything about how mixing occurs, how gradients are important, how heating occurs, how to make transportation of a solution inside the pipe. How does that change if it's a slurry? How to transport dried matter. Furthermore, thermodynamics. Again, a very important skill for any chemical engineer is understanding thermodynamics. What means boiling point? What are the vapor pressure charts? What do they mean? What is the importance of all these things? Because at the end of the day, you need to understand how energy moves and what are the properties of matter, thermodynamics by definition, to really be a good chemical engineer. So great, you have all this technical knowledge. Now it's your chance to show it. So what are scenarios? As I said, scenarios are 1 week long projects. You are put in a team, and for 1 week, you will be acting as a consultancy team. So you are technical consultancy team, which means you just focus mainly on technical aspects of chemical engineering. And let me tell you, they are challenging. They are equally challenging and rewarding. And I have some testimonies at the end. They are very intense. They are open-ended most of the time, very technical, very hands-on, very knowledge-driven. And now you will be working as a team. So at this stage, you will be developing your professional skills by working in a team. trying to understand how different people think, how the project needs to be driven forward. Again, you only have 1 week, it's 5 working days to deliver on a consultancy project. It is very intense, believe me. It is very intense, not only for students, but for lecturers, because there's a lot going on. And throughout the week, you meet with the client, and the client will be us, where you can come and say, we have looked at this, we have found this, does that fit the brief? Are you happy with this? Are you not? And we get to comment on your progress, we get to advise you in direction. But again, very intense, very hardcore. Seriously, there are students that feel very much scenarios, but the reward when you finish, the amount of things that you learn on different branches of chemical engineering is amazing. It's huge. And now I want to give you some example, and you will see I get very excited about this. So these are some examples of different scenarios that we covered. So urea production, why to make urea? But well, if I tell you that urea is probably 90% used as fertilizer and actually makes the world standings, it feeds the country, it feeds the world, then you can understand what is the importance of urea. Now, urea is made from ammonia. So we have another scenario, how to make ammonia. Why is ammonia important? And it's one of the most highly produced inorganic chemicals in the world. Why is this important? How to make it, okay? Moving forward, so this was when you develop the process flow diagram of how to make ammonia. In the next scenario, you get to identify, oh, there's actually a stream here, which has some fuel gas that can be used for something. Well, why not produce electricity from it? There you are. You have another scenario where the whole role is to produce a combined cycle power plant. We did some gas turbine building, heat recovery, steam generator, steam turbine. So you want to extract as much energy from that stream as possible. How to make that, what things you need to look out for. So you can see these are buildings, huge buildings. What things you need to look out for? Are they noisy? For instance, steam turbines are known for being very noisy. What do you need to do in order to cope with that? Gas turbines and air filtration, that's a whole room size of air filters. Why is this important? Etc., etc. Now, if you are more into storing electricity, I can tell you about lead acid batteries. Now, lead acid batteries or sulfuric acid batteries are very old technology, right? It's decades. But here, we are still exploring how to make them. If I may tell you, sulfuric acid is still used as a measurement of how developed the country is. But new uses are being used to be developed for lead acid. On their own, they are not very good as batteries compared to lithium-ion, but they can be used. Sulfuric acid can be used to regenerate other batteries. And looking ahead, again, research. This is something that we have in our own department. We are developing new batteries that actually use sulfuric acid with vanadium redox flow batteries that have huge lifetime of 30 years with more than 20,000 cycles. Your phone is about 1,200 cycles. This have more than 10 times as a large-scale solution. Now, if you are more into the fine arts, which is completely fine, we look also how to produce fine pigments. So in this scenario, we have our quarry extracting our pigment. It needs to be transported into a sprayer dryer plant. How do you transport? What pumps? How big are the pumps necessary for this? Also, when it reaches your spray dryer, how do you heat it up? Because heat control is very important in the fine pigments production. So you have a heat pump, and a heat pump is one of the most ecological solutions nowadays that are being used, for instance, to heat up homes. Now, if you are more into moving the world, we had a scenario recently about deciding. Your decision at the end of the scenario was, do we use batteries in the freight industry or do we use fuel cells? And all of them will have pros and cons, and it will be up to you with your research to understand, do we go with batteries, do we go with fuel cells? And we had a very special client. The client was a Departmental for Business, Energy and Industrial Strategy. So this is a department that is here in the UK that will be helping to make decisions at the UK level in order to understand how to move the country forward. Now, if you go the battery route, which is completely fine. You can see that the UK has no gigafactory. So a gigafactory is a factory that is able to produce gigawatts hour of batteries equivalent per year. And we don't have any. There are plans for it. But you will be able to explore what is necessary in a gigafactory, what is a production line, specifically how from the material you get into your battery pack assembly, into vehicle integration, and really focus also on the recycling. Why is this important? Where does these metals come from? What things you need to tweak, etc. Now, if you go the hydrogen route, which is also completely fine, you will notice that more than 90% of hydrogen actually, unfortunately, comes from fossil fuels. So that begs for the question, how do you produce hydrogen? In this scenario, that was exactly the plan. We were producing hydrogen. And for that, you need to understand what will be the reformer section, what will be the water gas shift reaction. But when you look at this, okay, where is this fossil fuel coming from? Well, here, typically, we have methane. So how do we get this methane from? That was another scenario, natural gas production. How do you extract methane from your natural gas, which is mainly methane, and how you make it usable? So that was another scenario, just focusing on the production and extraction of natural gas. Now you want to talk about biofuels. That's absolutely fine. Alternatives to liquid fuels. But what if I told you that the scenario was about producing biofuels in the Amazon, inside deep the Amazon? What are the constraints? What are the problems? What do you need to look out for when producing biofuels in the jungle? That was a decision. Should we go ahead with this project or not? At the end of the scenario, you will have to give this yay or nay in going forward with this bioethanol production. You have a lot of biomaterial available, but are the impacts on ethics, on the local populations there enough to justify this plant? Finally, pharmaceuticals. Again, we also have a lot of scenarios focused on chemicals production, but this one, a very specific one, pharmaceuticals. What things you need to look out for? How do you interpret this data in order to understand how to best create your materials for the APIs, the active pharmaceutical ingredients that will make your medicine? What things you need to understand? How do you design your crystallizers and all your your reactors in order to guarantee quality of your APIs? Some testimonies, guys. As I said, it's a lot of information, I completely understand, but these are third-year students that before going for interviews, we asked them, can you come and let us know what are the things that you enjoy more or not about scenarios? So this is copy and paste from information that the student has given us. Problem-solving skills, sim working skills, communication, organization, computational skills. They had a chance to use different programs, and decision-making skills. So these are all skills that they learned while doing these scenarios. As I said, very intense program, 6 scenarios and different teams all the time. It's a lot of information, a lot of to learn, but they got through and they were happy. What benefits they found? Again, this is a copy-paste from their information. Preparation for the real world, people working teams all the time. Scenarios made great examples to employers because not all of universities did that. So when you go and say, I was working in these scenarios as if I was a consultant, it adds a lot of information. And in no time, you'll be producing this type of PFDs or PNID in this case, which are very detailed with a lot of information. And that will be part of your design project in year 3. So if you want to learn more about that, you can attend next week's at 9th of June, where we have a lecture from the design team. This link, Mark will be able to post it. And they will be talking about the teaching process for plant design here at UCL Chemical Engineering. So this information all ties up with how to design finally and become a chemical engineer. Now, the last thing I want to touch on is about accreditation. Okay, the Institution of Chemical Engineers is the leading professional qualifying body for chemical, biochemical, and process engineers here in the UK. For short, we call the IChemE. It supports the development of chemical engineer professionals, developing a powerful network in more than 100 countries. It's a very recognized, a very reputable association. And once you finish your degree here, you are automatically part of it because our chemical engineering degree is accredited by the IChemE. Yeah, just to complement that, they support members in applying their expertise and experience to make influential contribution in solving major global challenges. So, in summary, guys, if you have a degree here at chemical engineering, you plus an accredited degree, that means that you will be able to get chartered in a reduced amount of time. And chartered is the ultimate recognition of our expertise as engineers here in the UK. Okay? Now, where to find more information? Again, UCL Chemical Engineering website. If you got here today, you probably are very aware of this website. But if you have any questions about the admissions, about the program, feel free to contact our undergraduate program admissions tutor, Dr. Federico Galvanin, and this is his email. And you will be able to help you with any questions you have about how to join UCL here and be part of our community. And that's it for me. I think now I will take some questions and I'll stop sharing my screen. Okay, so let's open questions and answers. Well, it has been one answer that has been asked. Any other questions? I can see chat. Oh, that's Mark. Any other questions that I can help you with? Feel free to put in the QA box and I will address them. Okay, I have a few questions coming in. So I think you mentioned this, but when will the scenario projects take place? Scenario projects take place over your first and second year. So because of their technical demands, they happen at the end of your first year and during your second year throughout. Okay, so then you have all the professional skills, the way to tackle problems, and technical knowledge to really get into your hands dirty with chemical engineering content. Now, does the chemical engineering program UCL offer summer research program for undergrads? No, it does not. As far as I know, it does not. We have some degrees that have an year in industry that are included as part of your program. But as summer research projects, you will be able to contact directly lecturers and work with them, but it's not an official part of the program. Now, another question, what skills would you say are the most important to have as chemical engineer? That is a good one. I find communication. And this is it sounds so obvious and so weak, but the truth is that engineering nowadays, it's done in teams. Some of them have tens of engineers in the same team. So communication is the most effective way to avoid redundancy of information, redundancy of efforts, and drive the team forward. So for me personally, is communication. Have good communication skills. Why isn't UCL Chemical Engineering course on UCAS yet? I don't know the answer to that. I believe it should be very soon out. I know there are some deadlines for that, and I'm pretty sure we are not over the deadline. So it could be just a matter of time before it gets updated. But I would recommend, if you really want this question answered, to contact Dr. Federico Galvanin. I'm sure he will be able to answer you without problems. How much chemistry, apart from the thermodynamics, is in the course at UCL? Now, one thing that I didn't mention, because it's part, well, it was not meant to be covered today, is that you will be able to choose other disciplines within your course, which are called the minors. That's what we call them here. And you will be able to choose between diversity, so breadth, or deep. If you want to go more into chemistry, there is a route actually that that allows you to finish chemical engineering with a chemistry specialization. Okay, with that you can have way more chemistry into your degree. But again, this is not a chemistry degree, this is a chemical engineering. But you are able to fine-tune your course to fit your chemistry questions or interests. Okay, so what modules does the IP include? The IP includes 4 main modules, which I already touched on all of them today. So design professional skills 1, mathematical modeling and analysis 1 and 2, so that's 2 different modules, and engineering challenges. So these are modules that you are directly interacting with other departments directly and making work together. What softwares would be helpful for prospective students to learn before starting a Chem Eng degree? Interesting. Well, we provide you with all the software that you will need to learn, and some of them actually is proprietary, such as MATLAB if you will need a license, or GPROMs. But for instance, GAMS is freeware. So GAMS is an optimization software, and you could start by learning it. Anything coding related would actually provide you with the base knowledge to have a head start when you come to UCL. Will there be any open days on campus? I actually will revert that one to Mark. Mark, are you aware of anything going on? I am honestly not sure.
Hi, Elton. So we're having a virtual open day on the 14th of June for prospective students. So yeah, you're all welcome to attend, and we'll have academics and student helpers on board to answer your questions. And there'll also be a presentation by Dr. Federico Galvini as well, who will be talking about the program. I'll share the open day link in the chat, and then you can register to attend.
Fantastic, thank you, Mark. Now, are there statistics relating to the employment of recent chemical engineering graduates? I know there are statistics available. I don't know where specifically, but I am sure that the open day will cover that, because Dr. Federico Galvani will have the answer for that question without doubt. So I'm sorry, I don't have this answer right now. Okay, we don't have any more questions. Anything else that you guys want to ask? Any other questions? Okay, we have a question now. How many lecture hours can we expect in a week during our degree? You can expect a minimum of 2 hours face-to-face per week per module. Okay, that does not mean you have other content online. You will have other content online, but you can expect a minimum of 2 hours face-to-face per week. Now, one thing that you need to understand is, coming to university, your job is to be a student. And that is a big difference in a mentality, a way to tackle problems. That here you'll be, your job, as I said, your job from potentially 9 to 5 is to be learning. Okay, so that is a big thing that actually clashes with students when you come from high school or A levels, that things tend to be more relaxed. When you come to university, it is assumed that this is your job. Therefore, the expectation is that you are doing normal working hours in order to cover your material. Okay, and believe me, if you do normal working hours, you will be more than prepared for anything we throw at you. I have a question. Can you do a master's in chemical engineering with a degree in chemistry? I don't know, because this goes into the remit of masters, and I don't teach in masters. I don't know personally what are the requirements to do the MSc in chemical engineering. My recommendation is that you go online to the chemical engineering website and you go to postgraduate courses. And there, I'm pretty sure you will be able to find what are the requirements for you if you want to do a course in Masters in Chemical Engineering. Any other questions? All right, so I have a question here again for admissions that I frankly, I don't think I'll know. For IBDP, are there specific subjects you have to take for chemical engineering? I don't know what is IBDP, to be honest, but I do know that you need specific A levels in order to join our chemical engineering program. I'm sure if you follow on the website, you will find what are the requirements to join our MEng or BEng degree, and what A levels you need to fulfill in order to be approved. Again, I believe the open day would be more interesting in answering these questions. So apologies for that. So if you have any final questions, now is the time. Okay, well. Okay, Mark, do you want to any final words to finish the session?
Thank you, Elton. Yeah, no, that was a great session. Thank you, everyone, for attending. If you do have any questions, do feel free to get in touch with the department, and yeah, we'll be able to answer your questions. Also, there'll be a feedback form you can complete at the end, and yeah, we appreciate any comments you can provide. Yeah, have a great day, and yeah, do feel free to get in touch. Bye, everyone.
Thank you so much. Bye now.